Hello, I'm Attakk, and let's talk about Snake. Now, everybody's probably seen Snake or played it at some stage. My personal experience of it was on an old Nokia phone in like 2001. But it's just, you're a little snaky, and you're moving in a straight line, and when you press a direction, he changes direction. You're trying to pick up these little fruities, and every time you pick one up, your tail becomes longer, and eventually your tail gets in your way, and you bump into it, and it's game over, and you're given a score. And next time you play, you try to beat that score. Now, we're going to try and make this. So, we're using TIC-80 because it's nice and simple, and everything we need is in here. We are making a new Lua script because I like Lua. It is nice and simple. It's a great first programming language, and you can get quite far with it. Just made a new file using Lua. Press escape, goes to your editors. Now, if this looks a little different from what yours does, it's probably because you have the retro font turned on. I prefer the slightly narrower font. You can change it by clicking that little switch font if button up there. And you can also, the button next to it turns off the shadow behind the text, if that's how you prefer. I leave it on because this is a bit easier to read on YouTube. If you close TIC-80 and open it again, this will reset. If you want to know how to make that permanent and also how to turn on dev mode so you can switch between your code and your running game faster and not lose the flow, check out the dev mode video on the other playlist. I'll link it below. Okay, this is the standard cart when you create a new cart. So let's quickly have a look at what this does. Just escape to go back to the console, type run to run it. You can also press Ctrl R or Ctrl Enter. It's this. So you have a little duty, which is the TIC-80 logo, and you can move him around using the arrow keys, and it says hello world, and he actually goes behind the text. That's what that does. Okay, how is this done? I just pressed escape. If you pressed escape and you got a weird menu thing, that's because you don't have dev mode on. Just go to close game and select it, and it'll boot you probably back to the console. Pressing escape goes to your code. That's what dev mode does, by the way. It disables that menu temporarily. Okay, so what's in here? There's some front matter stuff, some metadata. The most important one is this line that defines the scripting language that TIC-80 should expect. Then there's some globals, and this tick function is the beating heart of our little game. This fires 60 times a second, which gives us our 60 FPS frame rate. TIC-80 is locked at 60. But in exchange for that lack of control, it gives you consistency. So you don't have to worry about delta time or any of the complicated calculations that you normally have to do when scripting in a video game. It's taken care of for you. This does everything it can to run at 60 frames per second. In terms of code, there's not a lot. These 4 lines read the state of 4 buttons. Buttons, the clue is in the name. It checks whether the button is being pressed. If the button is being pressed, it changes the value of either Y or X, which are the globals up here. And then it clears the screen. It draws a sprite. Don't worry too much about this. That's just how it picks one of the 2 sprites. I don't know if you saw the little blinky eyes. At X coordinate X and Y coordinate Y, these are terrible global variable names. And then some information about how the sprite should be drawn. And then it prints the words hello world with an exclamation mark at a particular position. This t equals t plus 1 iterates the little t timer up here, which is used when picking which sprite to display. That's cool. There's actually a lot going on here if you're new to Lua or TIC-80 and you want to go through this, but we are going to use almost none of it. So let's rip out what we don't need. All the stuff. All we need is the buttons and clear screen. So, I haven't saved the card yet. Save Snake. So instead of drawing a sprite, let's start with just drawing a little square on screen. Just something we can see that we can potentially control. To draw a little square, we actually use the function called rect, because all squares are rectangles, but not all rectangles are squares. It takes an x value, a y value, a width, a height, and a color. Now the color, let's do that one first. Up here is your sprite editor, this little Pac-Man ghost, or you can press F2, like it says. Down here, don't worry too much about this, we're not going to use it. Down here, is our list of colors. Now, what color do we make our snake? Color 6, you'll see the index of the color pop up there. Index 6 is color green. Let's go with that. So color, we replace with the number 6. Now, I do want to use some of the code that's in here because our D-pad is manipulating these values. So let's keep X and Y the way it is, which means we'll be able to move this rectangle around the same way that the sprite was being moved around. For width and height, let's just put something arbitrary. I don't know, 2. Oop, that can't put a capital 2. Okay, save it and run it. And oh, that is not very clear, but right there, little green square, tiny 2x2 green square. Maybe let's make it a bit bigger. 4 by 4. Save and run. There we go. That's a little more visible, but still this light gray with the green is not the best color combination. Oh, and we can move it. Well, that's not much of a game. Okay. Next up, I don't know if you've noticed, but Snake works on a grid. The snake only turns if he lines up to one of the invisible squares in the background, which makes it easier for you as a player to line him up to the particular fruits in a horizontal or vertical fashion. So we can't be wiggling our little square everywhere. It needs to move specifically in straight lines, and it needs to be moving specifically on a grid. So step 1, we should probably make a grid before drawing our little rectangle. This runs in order, top down. So it's going to check the buttons first, then clear the screen, then draw our grid, and then we ensure that our little square, which we're now going to call the snakehead. Snakehead, one word? Whatever. Our little rectangle is drawn last, which means it'll be right on top. So to draw a grid, we're going to need, firstly, how big do we make the grid? So let's just switch to the sprite editor quick. A standard sprite in TIC-80 is 8 by 8, which is that size. I think that's okay. I think we can work with that. So 8. Let's make a global for this. Actually, let's put a comment in here that says globals so that we can put everything under here. And then we're looking at cell size. Now, because it's square, we don't have to have a cell width and a cell height, because it'll always be the same, because the whole game runs on a square. So 8. It kind of works because now our snake is 4 pixels and the square is 8. Okay, back to our for loop. For, we need to do columns starting in the top left corner. Okay, so TIC-80, just going to I can't run it when I'm halfway through a line of code. Let's do it. TIC-80 starts counting in the top left corner. X is obviously horizontal, Y is vertical, and it increases to the right and down. The screen is 240 pixels across and 136 pixels down, which is roughly 16 by 9. I think it is exactly 16 by 9, but it's not pixel perfect to HD. It's somewhere between 720 and 1080. So X0 starts on the left. We are going to go for the full 240 pixels of the width of the screen, and then this is an important value, the step. By how much do we increase _x every time we loop? I'm going to do it by cell size. Which means the first time this runs, x is 0. The next time it runs, it'll be 8. Then 16, and 24, then 32. Okay, but that gives us a point every 8 pixels running across the screen horizontally. Then inside this loop, we need another loop, _y. The reason I use underscores at the beginning of the variable name is to indicate that this is a throwaway variable. It is something we're going to use for this loop and then never again. So you can't, the value of this loop, the value of this variable is unreliable. So y also starts at 0. It's going until 136, and it's also increasing by cell size. Now, we have a horizontal point and a vertical point, well, a horizontal distance and a vertical distance, which gives us a point on a 2D plane. So what do? Draw little squares? Just draw a grid? Going to use rectangle again, but this time rect B, which gives us only the borders, and it doesn't fill it with a color. We need our X is X, our Y is Y that we calculated. Our width and our height will both be cell size. And our color will be 15, this dark gray, 15. Save and run. Hey, we have a grid. Now you'll notice that our little square is actually sitting neatly inside the top left corner of one of those cells. That's complete coincidence. The starting card just happens to have an XY coordinate that is divisible by 8, but the grid isn't doing anything to control our behavior, our movement, and how it's being displayed. This really is a terrible color. Maybe let's just make it white. Where is our snake head? 12. That's better. Okay. But now here's the thing. We don't want to be able to move it everywhere and move it ourselves. It should be moving of its own accord. And it should only change direction when it's in the corner of a particular cell. And then whatever we're pressing. So. Okay, first, maybe we should get some organization going here. The standard way of splitting up a game's flow is to have inputs, updates, and draw. Inputs looks at what the player is pressing on the keyboard or on the controller. Updates does any in-game logic that's required. And draw is in charge of taking everything after it's all changed and writing it to screen. So let's quickly clear out this TIC function and put everything in its own function. So for inputs, I'm just going to create a new function at the end. They're also going to have capital names because these are core functions. Okay, for inputs we want this. For updates, I don't think we actually have anything to put in here for now. And then for draw, we want the stuff that draws our snake head and our raw grid. I guess it is, because we're not doing anything with it yet. It's just a pure grid. Oh, and a clear screen. Oops. Selecting sections can be a bit odd in TIC-80. Okay. This goes in draw. So in TIC, we check inputs, we do updates, and then we draw. So inputs, buttons, updates, anything that needs to change, which there aren't any, and then draw, which does the drawing. So famous last words. If I did my job, nothing would change. Everything still works exactly the way it's supposed to. Okay, so far so good. Now, how do we keep track of the last direction that was pressed and only change direction when we hit the cell size? I think I just said it out loud without realizing it. So, we check inputs the whole time. We'll come back to change this because we won't be manipulating the X position directly. So we check inputs the whole time. Now updates is also being called by TIC, which means it also happens 60 times a second. But we know that we are on the corner of a grid position if our X position modulo cell size. Now modulo, that little percent sign, that's a percent sign. What that does is it does a division, but instead of giving me the answer, it gives me the remainder. In other words, if we take, I don't know, 15, 15, and we divide by 8, we get 1 with a remainder of 7. But that means if X is currently the number 15, X modulo cell size would come out as 7. if 8 divides by 8 or 16 divides by 8, it'll divide on a perfect whole number, an integer, and our remainder will be 0. So then we know in the x-axis we are now dead on one of the squares. But we need to check this for the y-axis as well. So y modulo cell size. Then, if both of these are true, then make snake change direction. Ooh, can I be ironic? To do. It's very lazy to do this in code, but if it's your own program, what does it matter? As long as you remember to go back and actually write the code that goes there. Now, instead of our button presses being mapped straight to our x and y coordinates, what we should do is store it in a sort of a buffer. So whenever you press the button, it just saves whatever the last button was that was pressed. And then when we hit our update, then it actually changes the direction to what it was, not when the button is being pressed. But when we change direction at the moment, we have two values, x and y, but only one of them is being manipulated at a time. So if we're moving vertically, only y changes. If we're moving horizontally, only x changes. And as far as I can think, the speed doesn't ever have to change. So we only really need one variable for this. So in our globals, let's make a variable for dir new direction new equals 0, which means it doesn't need to change. Or it should be the same as whatever direction we're moving at the beginning of the game. But that should be set immediately. Then, if up is being pressed, I'll bring up the layout, but you can also go to the console and type help buttons, and you get this nice little chart. 0 is up, 1 is down, 2 is left, 3 is right. So up, down, left, right. Up, down, left, right, like such. So if we're moving up, we keep it as 0. Let's do it clockwise. Something's going to be out of order. Either it's our button sequence or it's our final result. Up, right, down, left. That goes clockwise. So what did we call it? Dir new. That's not a very good name. Equals 0. One, 2, 3, 0, 1, 10, 2, 3. So either this is going to be out of sequence or this is going to be out of sequence. What am I doing? I like this being in order. The reason I'm using these numbers specifically is because later on when we're drawing sprites, this will also be our rotation. Because if you consider up to be 0, then each one of these numbers represents how many times we rotate by 90 degrees. To go to the right, you rotate 90 degrees once, then twice for down, then 3 times for left, and then 4 times would obviously wrap back up to up. So dir new would be able to tell us in which direction we're moving based on a single integer number that we can just read back. Now in updates, first things first, we actually need our snake to move. So we have an x and a y position that's changing. So x needs to be x plus. We're not saving this anywhere. So besides x and y, we're going to need an x direction and a y direction. X direction is going to be, for now, 0 and 0. We'll change that in a bit. X dir, and then y equal to y plus y dir. So at the moment nothing's happening, but theoretically as soon as we press a direction, this will be set. We're going to check this now to set the value up top, which will make these change. So if x and y, sorry, I'm yawning. If x and y are both, if we're in a new cell, this is when we actually read what the value is in dir new. So now we have to basically take that number back apart. If dir new is equal to 0, then I would love to do this with a switch or a case, but as far as I'm aware, there is no such thing in Lua. If the direction is up, then our y direction is negative, equals -1, -1. But we also have to reset our x direction because we are no longer moving horizontally. Actually, you know what? Wouldn't it make sense to just firstly reset both values? Because whichever one is being set is going to reset there and then be set as soon as it changes. Else if dir new is equal to 1, then we're going to the right, so x direction becomes 1. Else if dir new is equal to 2, then we're going down, so y direction needs to become, it's increasing 1. Else if dir new equals 3, then that's to the left, so x dir is equal to -1. If you're wondering why I'm not adding just an else, because there's only 4 directions, is because there's actually a 5th direction, and the 5th direction is no direction at all, which is what we're starting on. Let's move this down here, because it is possible for the game to not have started yet and for our direction to be 0. But as soon as we press a button, it'll change. Okay, let's see. This looks... Okay, this looks good. Let's run it. Uh-oh. Line 56, syntax error near double equals. Line 56, go to 57. You can't assign with a double equals. Double equals means we're comparing two values. One equals means we're setting a value. There we go. I don't know if this is working perfectly, because occasionally, like now, why does it look like he's sitting on top of that line? That should not be possible. Oh, because we didn't tell it what it needed to match. Okay, that should now always stop on a 0. And we're always in the top left corner of a specific cell. How big do we want this grid to be? 1, 2, 3, 4. I can't count that fast. Is SNCC usually square? I feel like the board is normally square. So if we have 136 tall, 17 cells. Exactly 17 cells. So should we take out 1? Or keep the one side of the board entirely SNCC right up to the edges, and then we keep the other side of the board for game related information like scores and so on. Maybe not, because maybe long term we want to add a little border around the outside of the playfield, and if we remain at completely and fully the height of the screen, there won't be space for that. So let's do 16 instead of 17. Cell size 8, grid size equals 16, because what I'd like to do is make it square. So where we draw our grid, instead of going up to 240, we're going up to cell size times grid size. And we're doing the same for height. Run it. Didn't I make it one less? Oh, I did make it one less, but what happens is it's 8 times 16 is 128, and when that for loop hits 128, it still goes one last time, because we're not actually looping 16 times, we're looping until we hit the multiplication of these two. So that problem will solve itself when we do the next thing. I want to move it slightly away from the edge, which is why we're going to be stopping there, so that I can move it a little down and a little right, so it's not in this corner. Let's just remove these numbers. Those are the modulos for the two directions that I used to double check why this thing was breaking. Okay, so I want to move this in and down by, if we're removing one row, then we want to move it half a row and half a column so that it's neatly centered. So border is equal to cell size divide by 2. Now this is just divide by 2. This is going to give you a float. If you put 2 divides, then it gives you integer division, so it rounds down. Okay. And then instead of starting, where's my for loop? Instead of starting at 0, we start at border. And instead of starting at 0, we start at border. Because what's going to happen now is this total is still 128, but when it gets to this loop, that'll be sitting at 132, which is over, so it won't render the last iteration. And run. Oh, that looks good. We do have the slight issue now that our pixel is now lining up to technically the center of each cell. So I should actually move it so that it lines up to the top left corner of the cell. So we're going to have to tweak how we do the position of the snake head and how we calculate when we hit modulo for the snake head. But we'll do that in the next one.